Thank you very much, and I certainly endorse the final comment of our previous speaker. The U.S. should certainly accede to the Law of the Sea Treaty. I also want to join my colleagues in thanking the conveners, the organizers, and particularly our hosts for this really wonderful meeting. One of the many remarkable benefits of the Law of the Sea Treaty has been the tremendous increase in high-resolution mapping data that has been collected in support of Article 76, and I'm very glad that Thomas provided that introduction to it for us, so I don't have to do it. It is quite complex, but it's led to mapping around many, many different nations. And nowhere is this increase in mapping more true than in the Arctic, where before recent continental shelf mapping efforts, there was virtually no high-resolution mapping data available at all. Even at the beginning of the 20th century, what lied beneath the Arctic ice was totally unknown. We see maps 1906, unknown region. And it really wasn't until Nansen produced his first chart in 1907 that it was suspected that under the ice was a deep ocean basin. And this is really quite remarkable because he did this based on 7 deep soundings, just 7 measurements with a lead line, and he had the intuition to realize that we had a deep ocean basin there. By the 1980s, based on many Russian ice station measurements, individual measurements from planes, we put together a picture of the complexity of the Arctic seafloor, but it was a very blurry and relatively inaccurate picture. And as the Law of the Sea Treaty was being negotiated, as I think Bjarni mentioned, the existence of a large promontory, the Chukchi Plateau, was known to the U.S. negotiators and of great interest to them. And again, as been mentioned, Ambassador Richardson made a statement for the record declaring that the United States considered the Chukchi Plateau and its component elevations ridges, not ridges, but submarine elevations. And within the complexity of the Law of the Sea Treaty, this has tremendous implications for how far you can extend juridical continental shelf. And there was no objection to that statement. Well, the U.S. efforts to map the continental shelf began in 2002 with a desktop study and the assumption that we would accede to the treaty, which is an assumption we still hold. The desktop study indicated, based on the knowledge we had at that time, that the foot of the slope, the starting point for everything, as Thomas described, looked something like that around Chukchi Plateau. And based on our understanding that the sediments of the Canada Basin were very, very thick, we would be constrained by the limit lines that Thomas described. And so an extended continental shelf, we thought at that time, would look something like that. It would be limited by the 350 nautical mile cutoff up there, way beyond the Alaskan margin, and then come around Chukchi Plateau like that. So a very large area, something like twice the area of California. Well, given this potential, we started to actually go out and map. You can't just submit a desktop study to the commission. You actually have to have real mapping data. And we were fortunate. We do have one icebreaker in the U.S. fleet that's working appropriately right now, and it's an icebreaker that's equipped with a high-resolution mapping system, something called the multi-beam echo sounder. In our very first year, in 2003, we went out basically seeing if it was feasible, because breaking ice is a very noisy endeavor, and trying to listen to a very weak echo returning from the seafloor is hard too. We didn't know if it would be possible, but we went out and it indeed was possible, and we were able to map, in this case, the beginning of the 2,500 meter isobath, one of the limit lines. And in doing that, we also discovered, totally uncharted, a 3,100 meter high, 10,000 foot high seamount, just one of many that over the years we've discovered that have not been charted at all. The Arctic is full of these things that we just don't know about. Over the next few years, we went back, continuing to map the 2,500 meter isobath, basically chipping away, but doing this in the context of plots that we've seen, this changing Arctic environment, the diminishing Arctic ice. Here's the reduction of the minimum ice extent in September, a reduction of 12% per decade. And we did this, again, working along until 2007, which at that time was the truly remarkable, extraordinary reduction in the ice. And this had quite an impact on our mapping. I've said many times that it's terrible for the Arctic, that reduction in ice, but it was actually very good for the mapping effort, because as we were heading north, looking for the foot of the slope at this time, at the top of Chukchi Cap, that zigzag pattern, what we found was no foot of the slope. We just couldn't find it. And given the ice conditions, we decided to just head further and further north, and basically found that the foot of the slope, which we had thought was located here was actually located here, almost 600 miles further north than we had expected. And this has tremendous ramifications on where you would put an extended continental shelf. And it also has ramifications on where a U.S. extended continental shelf would overlap with a Canadian extended continental shelf. And despite that, and despite many unresolved boundary issues with Canada, starting in 2008, we started a series of joint programs collecting data collaboratively with the Canadian icebreaker Louis Saint Laurent and the U.S. Coast Guard cutter Healy. And these have been tremendously productive. We work very closely sometimes, as you can see here. And in this picture, believe it or not, the Healy is actually backing down towards the Louis Saint Laurent to try to free it from the ice. And you can tell, of course, the Canadians there. The final year of our collaboration was 2011, where we had a truly remarkable cruise that brought us up to 88.5 degrees north. Again, collecting data that both countries are going to use collectively and collaboratively, and then let the lawyers and the diplomats work out the limitation of the boundaries. We finished our joint work in 2011 and went back alone in 2012. And I mentioned that 2007 was the previous ice minimum, but last year was absolutely amazing. And we can look at plots like this and get a feel for things changing, but you really have to see it to believe it, to see what this change was. And so in 2007 and 2012, we happened to be at the same place at the same time. Each year we had crossed the ice margin at about 75 degrees north. Every year, even 2007, into the ice at about 75 degrees north. But last year, in 2007, at 80 degrees north, this is what it looked like from the top of the icebreaker. And if we look at what this looked like, same place, same time of year, last year, it looked like that. There was basically no ice. You can see the ice margin way, way beyond there, more than 80 degrees north. So things have really changed. Let me try to summarize and say that we originally thought that the foot of the slope would look something like that around Chukchi Cap, with an extended continental shelf that would look something like that. What we've learned since is that the foot of the slope actually runs something like that, which again will have these huge ramifications. I should mention that we have no issue with overlap with Russia, because there we have a negotiated maritime boundary, but tremendous issues of overlap with Canada that are being negotiated right now. During this collection of data, we've collected more than 420,000 square kilometers of data. We've made that data all publicly available. We've learned many, many different things about the Arctic. We've been making acidification measurements. We've mapped and discovered pockmarks indicating gas expulsion features, new places where icebergs have grounded, or ice sheets have grounded, changing our views of Arctic ice history, and collecting samples, which are very, very rare in the Arctic, including the collection of fossil coral from more than 79 degrees north. We've literally basically changed the map of the Arctic with the data that we've collected with our colleagues. But the contributions are really, sadly, only coming from one side of the Arctic. If we look at all the contributions into the IPCAL compilation, the new bathymetric map of the Arctic, we're getting contributions from only one side. And I'm very concerned that our knowledge, our understanding, and our access to the Arctic will be very asymmetric. And so I'm hoping that in the spirit of this conference, we can encourage our colleagues on the other side of the Arctic to make contributions to these open databases too. So I've described the mapping we've done, but let me, referring to our previous speaker, put things in perspective and remind us that we've really only mapped 11% of the Arctic at this level of detail, and there's still much, much more to do. And let's not stop doing that. Thank you.